Current electricity. This is your new chapter, and in this video we shall study in details about current electricity. So I hope you still remember in unit 1, right? We have learned about the the electrostatic, which means the charge at rest. But in this chapter, we'll be studying again the property of charge, which is in motion, right? So also that when a charge is falling, or it is under the actions of electric field, then the charge will experience an electric force, which is given as F is equals to QE. Okay, where Q is the charge, E is the electric field. And if the charge is positive, then the directions of motion of the charge will be along the directions of the electric field. And when the charge is negative, the directions of motions of the charge will be opposite to the electric field. Okay. So in this, right, because we have seen here that a charge is moving because it experiences a force. So therefore, this moving of charge, or the motion of charge in the conductor, we can say it constitutes an electric current. Alright. So look at this circuit, a simple circuit diagram where we have, this is a conductor, okay, and the two ends of the conductor are connected to a cell. This is the positive terminal of the cell, this is the negative terminal of the cell. Alright. So now what happened is, we know inside a conductor we have a large number of free electrons. So these free electrons, as you know, right, they are moving randomly, right, okay, in the conductor. So because these two ends are connected to the cell like this, so it means this conductor now, right, it is under the actions of electric field, and the electric field that is present right over the conductor here, it is acting from left to right. That means from positive terminal towards the negative terminal, or we can say from left to right in this way, from positive to negative. This is the directions of electric field. Okay, so as I have told you that there are large number of electrons inside the conductor. So here I'm considering just one such free electron. So because this free electron is being negative, and this free electrons now it is subject to electric field, so this free electron now will be moving opposite to the electric field. So as the electrons is moving opposite to the electric field, it means the electrons now will be drifting towards the positive terminal of the cell. So in this way, the moving of electrons towards from the conductor to the positive, and inside the cell from positive to negative, again it goes from negative to the conductor, again it come back like this. So this continuous motions of electrons, it constitute an electric current. Alright, so we have seen also, right, in class 10th I think, that electric current is usually denoted by the letter I, and it is equals to Q upon T, where Q is the charge that is flowing through the conductor, and T is the time taken by the charge to cross the conductor from one end to the other end. Alright, so I name here as equation 1. So this equation means here that the current is steady. When I say the current is steady, mean the rate of flow of charge throughout the conductor, it is uniform. What does it mean? It means that suppose the time, okay, for 1 second, let's say the charge 1 coulomb cross from this end to this end of a conductor. Again for another 1 second, again what is the amount of charge crossing? 1 coulomb. Again for the next 1 second, 1 coulomb of charge always crossing the length of the conductor. So such flow of charge is uniform, and so we say the rate of flow of charge is uniform, and for that we write electric current is equals to Q by T, which is a steady current because the rate of flow of charges, it doesn't change. But however, when the rate of flow of charge is not uniform, that means for the first 1 second the charge crossing through the conductor is 1 coulomb. For the next 1 second the charge crossing, let's say, right, it is not 1 coulomb now, it is 1.5. So it is different from the from before. For the next 1 second, again, if you measure the charge, let's say it is 1.2 coulomb. Okay, right? So in this case, right, when the charge crossing through the conductor is not uniform with time, then the current, right, it is not a steady current. So in such a case, right, we defined a current, right, we determined, because the current here is not uniform, so we take the average current, and that average current here is known as the instantaneous current, and we write it as I is equals to dq by dt. So this is the equation for the current when the rate of flow of charge is not uniform.